Hey everybody, welcome back from Thanksgiving break. I hope you had a great break and got lots of rest. I certainly did. Um, I'm at home recording this on Sunday nights and I look like a hot mess, but you know what? I got a fire going behind me, so it's good. And I'm going to apologize up front right now because you may hear my dogs go ballistic at any point. So, all right. We finished up right before break about the mechanisms of evolution, and this is going to lead us into how species are distributed and into one of my most favorite things to talk about, endangered and invasive species. All right, so we are back on page 49 in your binder. So this graph right here, I think, is pretty easy to understand. It shows how species are distributed. We know that all organisms prefer a specific set of conditions: temperature, water, light availability, amount of oxygen, amount of sunlight, etc. So one of the best ways to show this is with fish, because fish really can withstand a wide range of conditions. So you see right here, okay, this is what we call the optimum range. So as you can see, in the optimum range, we have the most organisms, okay? So the optimum range right here is going to have the most organisms, or the highest survival rates, because these are pretty good conditions, okay? They're ideal. Now, the zone of stress, as you can see, there is one on each side. So you have low and then you have the high end. So if this is temperature. So if it's too cold or too hot, you can see there's a massive drop off in survival rate. So right here, very few organisms are surviving. Okay, so in the zone of stress, we have a major survival drop-off. And then lastly, the zone of intolerance right here. If it's too cold, if it's too hot, there ain't nothing that's going to survive there. Okay? So there is no life on either ends. Okay? So this is showing us a concept called ecological tolerance. Okay, so ecological tolerance is a range of conditions. You know, my handwriting is on point today. Look at this. It's a range of conditions such as temperature, which is what this graph is. So it's such as temperature, salinity. So hopefully you guys remember that is the amount of salt in the water. Flow rate, so how fast the water is flowing, and sunlight. That an organism can endure. Before death. So I actually have a funny story about this. So both of my children have betta fish in their rooms, and last summer, so to preface this, we have 2 cats in the house too. Last summer, my husband and myself and our 2 kids were sitting downstairs, and all of a sudden we heard this big crash upstairs, and we thought it was just cats being stupid, and they were, but we didn't know exactly what had happened. And so, you know, we didn't really want to get up at the time, so we sat there for about an hour, and finally we went upstairs, and one of the cats had knocked over my son's betta tank. So the water was all over the floor. The tank was on the floor, obviously, and we couldn't find the fish. And we thought that the cat had eaten it. And so, I'm sitting there, I'm saying a bunch of bad words, I'm cleaning all this stuff up, and my son goes, "Mama, what's that?" So I went over there and looked, and the betta fish, okay, had landed on my son's backpack that had like the vinyl covering on it. So, y'all, I'm telling you, this fish, we thought it was dead. Okay, so my husband picks it up and goes to put it in the toilet. Okay, and he's about to flush, and I'm in there, cleaning up still, and my husband goes, "Jennifer, can you come here for a minute?" I was like, "Okay, what?" So go in the bathroom, and my husband, he looks at me, he goes, "The fish is alive." I was like, "What are you talking about?" So he hadn't flushed the toilet yet, and I looked in the toilet, and the fish is swimming around in the toilet. I was like, "Oh my God." So he ran downstairs and got some more of the spring water, filled up the tank again, and y'all, this is true love from my child. I stuck my hand in the toilet. Now, there wasn't anything in the toilet except for the fish and the water, but I stuck my hand in the toilet, I grabbed the fish, and I put the fish back in the tank. That fish survived for like another 5 months, I'm telling you. It was the weirdest thing ever. Anyway, ecological tolerance right there, okay? All right, so let's look at niches. So you guys may have heard this term being used in conversation, but it's probably not the correct way it's used or the scientific way that we talk about it. So a niche basically is what an animal does in an ecosystem. It's the role that it plays, okay? So a niche, let's write this down, is the role an organism plays. Okay? So, let's look at this amazingly incredible, very interesting example of barnacles. All right? So, barnacles are one of those organisms that live in that intertidal zone that we talked about, where there's different temperature conditions and different water and different oxygen and sunlight and all that kind of stuff, okay? So, we have 2 different types of barnacles in this example. And y'all, I am not even going to try to say their names. We're just going to say brown and blue, all right? So, when we look at the brown one, okay, this shows us what we call as the fundamental niche. So right here, the fundamental niche. The fundamental niche is the theoretical set of conditions. Okay, it's a theoretical set of conditions where a species can live. So we can hypothesize all day that this brown species of barnacle can live all up and down this rocky cliff. It can live underwater, it can live above water, it's everywhere, okay? Now, when we look at it actually in nature, it doesn't really do this, does it? If you look at the picture, guys, look what happens. It's only up here at the top. So it has a much more limited set of conditions that it actually can survive in. So this is what we call the realized niche. So the realized niche is where it actually exists. Okay? So the realized niche. Oh, what's happening? Oh, okay, y'all. is where it actually exists. Okay, that's the difference. Theoretical, what we think it'll do, and then realize what it actually does. Okay, all right, so let's look at some endangered species. Now, we talked about the generalist versus the specialist. Okay, so we know that the generalist is going to be more like an R-selected species, right here. Here's our raccoon, our trash panda. Okay, so this is going to be R-selected. They can withstand a much broader set of conditions. So if you look right here, it has a much larger niche. Okay, so it has a larger niche. It's not as picky where it lives. Now, then you've got your specialist series, and these are going to be our K-selected. And if you see right here, it's much narrower. So it's a narrow niche. Okay, that's how those two are different. Now, there are regions where they can overlap, but as you know, this can lead to competition, which animals honestly try to avoid at all costs because it leads to death. All right, so I'm going to stop right here because then we're going to be getting into our endangered populations, our endangered animals, and I want to start with a fresh video.